far as ignition coil is concerned, as I quoted in the previously, ignition coil, it is nothing but a transformer. You can see the figure, you can see it consists of a centrally laminated iron core, and here you can see the positive primary terminal, you can see negative primary terminal, you can see the primary winding, you can see the secondary winding. The primary winding will have around 400 to 600 copper turns, copper wire turns, which will have around 20 gauge, whereas secondary winding will have 20 to 30,000 turns of copper wire with 40 gauge thickness. Okay, and you can see as far as the ignition coil is concerned, it is nothing but a transformer. It consists of two windings, you can see primary winding and secondary winding, and centrally it is having a laminated iron core. And this ignition coil, it will produce the magnetic field. How it produces magnetic field? It will take low voltage and in low voltage current from the battery. As I said, battery, generally the battery, it is with this 6-volt battery or 12-volt battery. It will take 12-volt battery as input to the primary winding. Once when 12-volt battery is passed through the primary winding, magnetic field is induced, and it is passed through the triggering switch, and magnetic field collapses. That we are going to see in the next figure, and it produces the magnetic field. As far as the ignition coil is concerned, ignition coil is a high voltage current coil. It is a transformer which transforms low voltage, that is 12 volt or 6-volt power to 20,000 to 30,000 volts, which is required for producing the spark in the spark plug gap. When 12-volt current is applied across the primary winding, it generates a magnetic field. Once when the 12-volt, you can see, once when the 12-volt current from the battery, it is passed through the primary winding, it produces a magnetic field. Okay, a magnetic field, which in turn generates a much higher voltage in the secondary winding by collapsing the magnetic field which is produced by the primary winding. And this high voltage, it is produced that much of high voltage which is sufficient enough to produce a high intensity, high temperature spark in the spark plug gap. This is what you can see in this, and you can see what you can see here. It is the skeleton of this coil. You can see primary winding and you can see secondary winding. The number of turns, copper to wire turns are less in primary winding. You can see the secondary winding, the number of copper wire turns are more. Okay. Now, the types of ignition system. We have generally 3 types of ignition system. One is battery ignition system, another one is magneto ignition system, another one is electronic ignition system. This electronic ignition system is also called distributor-less ignition system. Generally, this battery ignition system and magneto ignition system, all of you concentrate here. Battery ignition system, magneto ignition system, these systems are referred as conventional ignition systems. Battery ignition system or magneto ignition system, these are the 2 kinds of ignition system which are referred as conventional ignition system in case of spark ignition engines. Whereas the electronic ignition system or distributor less ignition system. This is used for heavy duty purpose according to the need of the engine, according to the requirement of the engine. Okay. Now, as far as this battery or coil ignition system is concerned, now we'll discuss first the battery ignition system. The battery ignition system has, you can see on the screen, has 6 or 12-volt battery. Generally, two kinds of battery it is used: 6-volt battery or 12-volt battery. A battery ignition system has 6 or 12-volt battery charged by an engine-driven generator. For charging, already the whatever the power it is generated by engine, it is charged with this. A battery ignition system has 6 or 12-volt battery charged by an engine-driven generator to supply electricity. Where it supplies? It supplies to the ignition coil. An ignition coil is there. An ignition coil is another component used in battery ignition system. This ignition coil is used to increase the voltage, which we have seen in the previous figure. And another device we have, that is called triggering switch device. This device will interrupt the current in the coil. How it interrupts? By collapsing the magnetic field which is produced by the primary winding of the ignition coil. And a distributor, another component will be there, which you can see in the next figure. A distribution coil will be there, a distributor will be there. This will distribute the high voltage which is produced by the ignition coil to different spark plugs for producing the spark. And another component, as we know, spark plug, this plays very important role. And how much intensity, what is the temperature of spark, will define how fast the ignition will take place. Okay. And this is what it is. And the current goes, as I was telling, the current goes from battery through the primary winding of the coil, through the interrupting device, and back to the battery. What battery will do? Battery will supply current to the primary winding of ignition coil, and this current, it passes to the interrupting device, and again the same power, it goes back to the battery. Again, I will repeat this. The battery ignition system will have this requirement. Battery ignition system has 6 or 12-volt battery. It is having an ignition coil which is used to increase the voltage. A device, that is the triggering switch, which will interrupt the current in the coil by collapsing the magnetic field. A distributor, whatever the high voltage current which is produced by the secondary winding of ignition coil, this distributor will distribute that high voltage current to different spark plugs according to the number of cylinders. And the battery will supply the current, and the current supplied to the primary winding, and it goes to the interrupting device, and again the same current, it goes back to the battery. And here the battery ignition system will have two circuits. One is primary circuit and another one is secondary circuit. As far as the primary circuit is concerned, the primary circuit will consist of battery. The primary circuit will consist of ignition switch. The primary circuit will consist of primary coil, and the primary circuit will consist of breaker points. This is also called triggering switch, and it also consists of capacitor. And this is how the primary circuit it consists. As far as the battery is concerned, as already it is explained, it provides the required power to run the system. Okay. And ignition switch, it is controlled by the driver, which is used to turn the engine on or which is used to turn the engine off. And the primary winding, primary coil of ignition coil. As already we seen in the previous figure, ignition coil will have two circuits. One is primary coil, secondary coil. Primary coil will have primary winding, secondary coil will have secondary winding. Primary coil will produce the magnetic field to create high voltage in the secondary coil. Primary coil will produce the magnetic field to create high voltage in the secondary coil. Secondary coil will consist of secondary winding. Okay, and the breaker points, and this breaker points, it is also called triggering switch. Okay, this breaker point, it is a mechanical switch which will act as a triggering mechanism for collapsing the magnetic field which is produced by the primary winding in the ignition coil. And as for the capacitor, one more component. This capacitor is also called condenser. This capacitor, the main function of this capacitor will protect the breaker points from burning or from pitting. The capacitor or condenser, it will protect the points from burning out. This is how, what about the primary coil, this thing circuit. And the secondary circuit, in case of battery ignition system, the secondary circuit in case of battery ignition system, it consists of the secondary coil, it consists of a rotor, it consists of spark plug. As far as the secondary coil is concerned, as I said, secondary coil will have secondary winding. The primary coil, which we have seen in the primary circuit, will have primary winding. And in primary winding, the number of turns are 400 to 500. In case of secondary coil, it will have secondary winding. Will have around 20 to 30,000 of copper turn with a thickness of 40 gauge. Okay, and the main function of this secondary coil, it is that part of the ignition coil which creates the high voltage electricity which is required by the spark plug for producing the high intensity, high temperature spark. Again, I will repeat, the secondary coil will have the secondary winding. It is that part of the ignition coil which creates the higher voltage electricity which is required for producing the spark in the spark plug. Okay, and another element of the secondary circuit of this battery ignition system, this is the rotor of the distributor. This is very important portion of this rotor. It will be available in the distributor system. This rotor will spin around at the top of the distributor shaft, and this rotor will distribute the high voltage electricity to different spark plugs for producing the required high intensity spark according to the ignition order, according to the firing order. And as far as the spark plug is concerned, this spark plug will take the electricity from the wires and give the high intensity spark, and this spark, this is responsible for ignition of the compressed charge at the end of the compression step. Again, I will repeat, the secondary circuit of the battery ignition system, it consists of the secondary coil, rotor, spark plug wires. The secondary coil, it consists of secondary winding. It is that portion of the coil which is responsible for creating high voltage electricity which is required for producing the spark in the spark plug. And this rotor, it is the rotating element of the distributor. It rotates. During this rotating of the rotor, whatever the high voltage electricity received by secondary coil of the ignition coil that is distributed to different spark plugs at the right time according to the firing order of the engine. Are you getting? And spark plug, it will produce the high intensity, high temperature spark, which is responsible for ignition of the compressed charge at the end of compressed or compression stroke. Yes, this is the, you can see this is the figure of the battery ignition system. You can see the different, you can see first the battery is there, all of you see the figure, battery is there and the battery is grounded and battery is connected to the starting switch, and that battery again it is connected to the ballast coil, or this is ballast coil is also called ballast register. This is called ballast register, and here you can see the primary winding and here you can see the secondary winding, and this ignition coil is, you can see it is connected to the breaker points or triggering switch, and this ignition coil is connected to the distributor, and the rotor of the distributor is connected to the different spark plugs. Okay, and here you can see, as you know, the battery, it supplies the required power to the ignition coil. Okay, and one more this thing, you can see the switching starting switch. This is starting switch, as I said, it is controlled by the driver to switch on the engine, to switch off the engine, and this starting switch is connected to the ballast register, BALLAST, ballast register, and this ballast register is placed between starting switch and the primary winding. It is placed between the starting switch and the primary winding of ignition coil, and you can see the secondary winding, and you can see the ignition coil is connected to the, where it is connected to the breaker points, and the breaker points again you can see it is connected to the condenser, or condenser may also be called as capacitor, both will have same thing. And this ignition coil is, again I'm repeating, it is connected to the distributor, and this ignition coil secondary winding, it is connected to the rotor of the distributor. Okay, this is how. And here one more important which I have not explained earlier, the ballast coil, which is placed between starting switch and the primary winding of ignition coil. Okay, the main function of this ballast register is to prevent the overheating of primary winding. Okay, the major function of this ballast register, it prevents the overheating of primary winding of the ignition coil, and this ballast register, it is placed between starting switch and primary winding of ignition coil. Again, as far as this ballast register is concerned, it is generally connected in series. Note down, ballast register or ballast coil, it is connected in series, which regulates the flow of current to the primary winding, which is received from the battery, And here you can see the contact breaker, which is connected to the ignition coil. The contact breaker, it is regulated by the cam. Here you can see the cam. The operation of this operation means the contact breaker. These points A and B are there. They should be brought in contact, and they should be brought away from the contact. So the closing of these A and B points and opening of A and B points, it is operated by the cam, which is connected to the engine crankshaft. Okay. Now, as far as this contact breaker, the opening of contact breaker, the point A and B, the closing of the contact breaker, it is operated by the cam. Which is placed on the crankshaft, and this crankshaft is connected to the engine is camshaft. The camshaft is connected to engine crankshaft. Okay, and one more element which we have not seen in case of earlier figure. So this, the main function of this distributor is used in multi-cylinder engines. Distributor, it is used, battery ignition system itself is used in case of multi-cylinder engine, and this is one of the very important components in distributor, which is connected to the ignition point, and this distributor is used in multi-cylinder engines. There are two types of distributors presently used. One is carbon brush type. You note down, if you have paper and pen, you note down the two types of this thing which are used presently. Carbon brush type of distributor, this is one type of distributor which is used. Another one is gap type distributor, gap type of distributor. First one is carbon brush type, carbon brush, BRUSH, carbon brush type distributor, gap type distributor. These are the two types of distributors which are used, and the main function of this distributor is, here it consists of a rotating element. This rotating element, once when the high voltage is created in the secondary coil, winding of this ignition coil, the rotator starts rotating, and this high voltage which is received by secondary coil or secondary winding, it is distributed to the different spark plugs at the right time according to the firing order of the engine. And as far as this condenser or capacitor is concerned, I was explaining in the previous this thing, the main function of this capacitor, this thing is, it prevents the overheating of what is this, the contact breaker points A and B, or it prevents the pitting of contact breaker points. And this is how you can see. And the one more figure which is still more easier for you to understand, this is another figure, and even this figure, it is easy for you to follow and easy to draw also. The same thing, it is I have taken from a different source, which you have the complete idea about this. Battery is there, emitter is there, ignition switch is there, and you can see the primary coil I was quoting in the previous. Primary coil, it consists of primary winding with 200 to 300 turns of 20 gauge wire. This wire is made up of copper. This wire is made up of copper. And the secondary coil, it consists of secondary winding. It consists of 20 to 30,000 copper wire turns with a 40 gauge thickness. With a 40 gauge thickness. It is very, very thin. Okay. So this is how you can see. And as far as the working principle is concerned, just I will explain you how this works. Just you concentrate how this battery ignition system works. You just concentrate. I will explain one by one how this entire system works. How this entire system works. In this system, you can see the ignition switch is there. If the ignition switch is on, which is, as I said, it is controlled by the driver. If the ignition switch is on, that means engine starts running. Okay. Once when the ignition switch is on, the current from the battery, so you can see the battery. The battery may be either 6-volt battery or 12-volt battery. Once when the ignition switch is on, the current from the battery, it starts flowing through the ignition coil. It starts flowing through the primary coil of ignition coil, primary circuit. And again, it just this current starts from battery. It goes to the ballast register, then it goes to the primary winding, then it comes to the contact breaker. Again, I will tell you, here the ballast register is not placed. Even this, before this primary coil, the ballast register, which you can see in the previous figure, This is the ballast register. First, when the ignition switch is on, when the ignition switch is on, the current from the battery, it flows to the primary circuit by passing through the ballast register. As already said, ballast register, it is placed between starting switch and the primary winding of ignition coil. Okay. Again I will repeat, as the ignition system, as the starting switch is on, that means ignition is on, the current from the battery, it starts flowing through the primary circuit and through the ballast register, through the primary winding. You can see the primary winding and to the contact breaker. And once when the current which is flowing through the primary winding, once when the current which is taken from the battery, it is flowing through the primary winding. The primary winding here, it induces a magnetic field. It induces a magnetic field around the primary winding. Once when the current is flowing through the primary winding, the primary winding starts inducing a magnetic field around it. Okay. The more the current primary winding receives, the stronger will be the magnetic field. Now, once when the ignition switch is on, the current from the battery, it flows to the primary circuit, it flows to the ballast register, it flows to the primary winding, and once when the current is flowing through the primary winding will induce a magnetic field around it. The more the current passing through the primary winding, more will be the power produced. Okay, more will be the magnetic field produced. Once when the contact breaker opens, once when there is no contact, once when the contact between this point A and B is removed, the current through the primary winding collapses. The current which is passing through the primary winding, it collapses. And this immediate collapse of the primary winding, the magnetic field of primary winding, this induces a voltage of about 300 volts in the primary winding. Once when the magnetic field which is produced by the primary winding, it starts collapsing. How it collapses? The contact breaker points opens. Point A and B, there is no contact between them. It opens. Due to opening of this contact breaker, what happens is the magnetic field which is induced by the primary winding, it collapses, and there is just an increase in the voltage of the primary winding. It may be around 300 to 500 volts, which is much higher than the voltage which is received by the battery as input. Okay, and this voltage induced in the winding charges the capacitor. Whatever the higher voltage which is induced in the primary winding, it passes through the condenser or the capacitor, which charges the capacitor. Okay, as this condenser or capacitor is charged, the current through the primary winding stops. Once when the condenser is charged, once when the capacitor is charged, by then what happens is the current which is passing through the primary winding, it stops, and this reverses the direction of current of flow. How it reverses? Again, now the current start flowing from the condenser to the primary coil, and again this current goes back to the battery. It goes back to the battery, and there is a reverse in the flow of current, and the magnetic field which is induced by the primary winding. Due to this, the secondary winding will produce a very much higher voltage, and this voltage is of the range of 20 to 30,000 volts. Due to collapsing of the magnetic field, due to reversing of the current, just concentrate here, due to collapsing of the magnetic field which is produced by the primary winding, and due to the reverse current flow from capacitor to the primary circuit back to the battery. Due to this reverse current flow and due to collapsing of the magnetic field, a very high voltage of the order of 20 to 30,000 volts is produced by the secondary coil, that is secondary windings. And whatever this high tension, high voltage current which is produced by the secondary coil, it flows to the distributor. And as I said, this distributor, it is having a, at the central you can see a circle, this is called rotor. This is a rotating element, it rotates. The distributor, you can see it is having a rotor which rotates the over the distributor cap. Okay, as the rotor starts rotating, what happens here is whatever the current which is passed, whatever the high voltage which is produced by the secondary winding, this high voltage current, it is distributed to different spark plugs at right time according to the firing order of the engine, whereby a high intensity, high temperature spark which is produced, and that is responsible for ignition of the compressed charge at the end of the compression stroke in spark ignition.